Hello, hi everyone. Welcome back to sisyaclass YouTube channel. So in today's session, we are going to learn about thermodynamics. So another chapter from your physical chemistry. So in the last session, I hope you have revised the questions. I hope you have solved questions from your side. We have covered states of matter in the last session. A lot of numericals we have covered there. And I hope you have practiced many more questions after that because the content was simple. Okay. So before we start, I have a small information for you. Then we are going to begin with our session for today. Okay. All right. So we are starting with a new maths course at just ₹999, in which you will get 1 year course for grade 3 to grade 10 from all IIT, NIT faculty. They will teach you in Telugu, in English and Hindi also. So you can choose in which language you want to study. Okay, so you can download the sisyaclass app and you can take help of Sysya AI also, in which you can ask your doubts. Okay, so there are features such as text to text doubt solving, image to text doubt solving, speech to text doubt solving. So you can ask your doubt from there. There will be expert mentors provided to you, and this course that we are providing at just ₹999, if you calculate the cost per day, it comes out to be less than even ₹3. So take help of the course. It will cover the entire CBSE, ICSE and your state board syllabus. Okay, so this was the information that I wanted to give you. Now let's begin with our session for today. Before we start with our session, let me introduce myself. All those who are following the EAPCET series, they already know about me. So I am Nidhi. I am from IIT Bhubaneswar. I have 6+ years of experience teaching NEET, JEE and other competitive examination. And in today's session, we are going to understand about EAPCET. So we are going to talk about the topic of thermodynamics, how we are going to proceed in today's session, just like we do always. We are first going to understand the content. We are first going to understand some important concepts. And after that, we will move forward with our questions, and those questions we are going to understand the concept there also. Okay, something new pops up, we are going to understand the background behind it. Then I will tell you how you have to proceed in that question, and after that obviously you can solve it. Okay, so let's start everyone. Let's start with the content for today. So what are we going to discuss today? Since we are talking about thermodynamics, very important, very important chapter. And it is easy provided you know the formulas. And if you think physical chemistry is hard, I can't solve numericals, it is very difficult for me, then it will remain that tough and difficult topic only. But if you think, yes, I can solve the questions, yes, I can memorize the formulas, yes, I can substitute the values, then it will look easy to you. You have to practice more and more questions obviously, but don't fear the chapter that I can't do numericals, I will just go with organic chemistry or inorganic chemistry, let's leave physical chemistry. Don't do that. Okay, you should have the entire package with you. You should know all the 3 parts of chemistry, then only you will score good marks. Okay, so what are we going to discuss today? We will learn about first law of thermodynamics and some basics of thermodynamics. For example, extensive and intensive properties, we will learn about them. How do we identify this one is extensive, this one is intensive? We will take some examples. You will see so many questions are asked from there. So systems, surroundings, some of the basics we will cover, and then we will move with our first law of thermodynamics, in which we talk about the internal energy change. So we will learn about state function, path function and everything related to it. Okay. After we are done with the first law of thermodynamics, we will talk about the different laws of thermochemistry also. So these are the topics on which we will solve questions also today. Okay, so laws of thermochemistry, simple unitary mathematics. Again, you should know the definition of different types of heat changes, different types of enthalpies. After that, you will find the questions are so easy. Okay, so we will cover such questions in which you just have to do the calculation, but please don't do silly mistakes while calculating things, because that is all you have to do. Okay, then next we will talk about entropy changes and our second law of thermodynamics. Finally, we will talk about the spontaneity of the reaction. How do we identify this reaction is spontaneous, non-spontaneous? How is delta G going to change because of that? What is the relationship between, let's say, delta H, delta S, their sign, and how do we decide the spontaneity of the reaction? At which temperature the reaction will be spontaneous, non-spontaneous? Such questions are asked so many times, and there is a small table that we will study today. Based on that, you can solve any question related to that. Okay, that sign based question, you must have seen that question, in which they give you the sign of enthalpy and entropy, and they will ask you whether the reaction is spontaneous or not, and if it is spontaneous, at which temperature. You can easily answer that question after that. Okay, So we will talk about the spontaneity and our Gibbs free energy and how do we calculate it. Okay, so we will understand about the enthalpy calculation for a chemical reaction also. So these are the things that we will cover today. Let's start, everyone. Hi everyone, hello. I am just introducing the topic, Charan. Okay, we are going to understand the content slowly. Okay, this is just basic introduction, that is all. Okay, so let's start, everyone. So first of all, you should know how do we calculate the work that is done in a particular process. Now for that, you must know what type of process we are talking about. They will just write in the question that calculated for irreversible process or reversible process. You have to decide which formula to use. And in some cases, they will not directly tell you whether the process is reversible or irreversible. So there are chances that they will ask you to read the question carefully and decide for yourself what type of process we are talking about. Okay, so we will learn one simple trick by which you can decide whether we are talking about a reversible process or an irreversible process. Okay, so see the formula, everyone. Work done is minus P external delta V. This is our general formula. Now we are going to expand it for a reversible and irreversible process also, and you have to remember the formula separately. You have to apply the formula based on the question that they are asking. Okay, so what is this? This is external pressure, this is change in volume. Okay, so work done by the system, there is some sign convention also involved. Based on that, you will decide whether the work done is positive or negative. We will cover that also. And you have to keep in mind the sign convention is very important. Let's say you have solved everything. Okay, you have calculated the work done also, you have calculated the heat change also. Finally, you are trying to calculate the internal energy change, correct? But you don't know the sign of work done, you don't know the sign of heat that is produced or released. Then how will you come to the correct answer? So sign convention is very important. We will learn about it. Note it down. Please remember it. Okay. So this is my general formula. Okay. This is external pressure, which is constant. This is change in volume. Okay. So this is how we calculate the work done in case of a irreversible process. What kind of process, everyone? Irreversible process. So if the examiner is very helpful, he or she will write it in the question itself that please calculate it for an irreversible process. Otherwise, how are we going to decide? This formula we have to use. If you see constant external pressure, you have to remember we are talking about a irreversible process. Okay, so constant external pressure is our hint. If you see constant external pressure is mentioned, remember we are talking about an irreversible process and use the formula. Okay, see the next part. Sign convention, as I have told you about. Expansion, do we have to remember it based on expansion or compression? No need. Okay, expansion, volume is going to increase. Common sense, expansion, something is expanding. Initially you have taken, let's say, 2 liters of some gas. Now it has expanded to 4 liters, expansion, right? So what will be the change in volume? Final volume minus initial volume, it will come out to be positive, right? Do we have to cram this information? No, common sense. Okay, so if we are talking about expansion, the change in volume is positive. So what about work done? Is it positive or negative? Work done is negative. Why? Minus P external delta V, right? If this quantity is positive, do we understand the overall term will come out to be negative? Again, common sense, no need to cram it. What you have to remember, if you substitute the values, obviously you will come to know whether it is positive work done or negative work done. That part is simple. But what if they give you a statement that work is done on the system, that work is done by the system? In that case, you have to memorize. So please remember, if some external force is doing work on the system, then it is positive work. But if the system is doing the work is done by the system, then it will be negative. 2 things I have told you. Work done on the system is positive. Work done by the system is negative. This information you have to memorize, otherwise you will do something wrong. Okay, this expansion and compression, you will come to the observation by substituting the values itself. There is no need to remember it separately, not required. If you know this formula, you will come to this observation yourselves. No need to cram it. But this part you have to remember, that work done on the system is positive, work done by the system is negative. Okay, what else? Heat is absorbed by the system. System is absorbing the heat. It is positive. System is releasing heat. Heat is released from the system. It will be negative. See? It is positive, released, negative. So if you add energy to the system, simple way to remember. If we add energy to the system, always positive. If system is releasing energy, it will be negative. Like that you can remember it. Okay, see something similar we have written here. Energy absorbed by the system. You are adding energy to the system, positive. You are removing energy from the system. System does not want to give the energy. It will be negative. Okay, see, energy released by the system is negative. So this is the sign convention that you have to remember, that you have to memorize, then only you can solve questions. And where are we going to use this entire set of information? We are going to use it when we are going to solve questions related to first law of thermodynamics. When you will calculate the internal energy change with the help of heat exchange and work done, you will use this entire set of information. Okay, so this part is done. Now let's move to the next thing. See, internal energy, it is the total energy within the system. Can we calculate the absolute value of internal energy, the total energy? It is the sum of all the different types of energy which are present in your system. Can you calculate it as a whole? We can't. So what should we do then? We don't talk in terms of absolute energy. We talk about change in internal energy. We talk about change in enthalpy. We talk about change in entropy. You will see. Okay. So total energy within the system is internal energy. We are concerned with change in internal energy, and this is how we calculate it. This is change in internal energy, heat exchanged plus work done. And the sign convention you will decide based on the information given to you in the question, that if heat is added to the system, we will call this as positive. Heat is removed from the system. Already we have covered that part. We are just revising it once again because the information you have to apply here. This was the first law of thermodynamics that I told you about. Okay, so heat removed from the system will be negative. Work done on the system, positive. Work done by the system, negative. As simple as that. Okay, so heat added, positive. Heat removed, negative. Work done on the system, positive. Work done by the system, negative. So this is the sign convention, and you have to use this information when we are going to solve questions. So please keep this thing in mind. Okay, memorize it. This is very, very important. Okay, let's move to the next part then. Isothermal, see, I told you about the type of process will tell you which formula of work done you have to use. So for the irreversible process, I told you, look for constant external pressure. For the reversible process, you will not see anything related to constant external pressure. First thing, they will give the information directly to you in the question. So for irreversible process, you have to scout the entire statement of the question for the word constant external pressure. And if you don't see any constant external pressure written, understand we are talking about a reversible process. Okay, so for the reversible process, isothermal reversible process, how will you calculate the work done? By using this formula. This is natural log. What if we want to calculate it in terms of logarithm to the base 10? We can do that also, like this. V final over V initial, or you can write it as V2 or V1 also, up to you. You have to know the representation. Rest everything is written here. What if they give us in terms of pressure? We can calculate it in terms of pressure also, like this. but please notice we are going to write P initial over P final here. Boyle's law, volume is inversely proportional to pressure. So if we are writing V2 or V1, I want to write the same thing in terms of pressure, I have to write P1 over P2. Okay, so that is why I have written Pi over P final, not P final over P initial. Please keep this thing in mind. Don't write P final over P initial, don't substitute that value. Okay, so this part is done. So N is number of moles, R universal gas constant. You already know the three values of universal gas constant. I've repeated this information in multiple sessions we have already done. So all those who are following the sessions, all those who are solving the questions, they are now very well aware of three values of universal gas constant. I hope you are following that. I hope you are noting it down and solving questions based on that. Okay, so R universal gas constant, T we will always take in Kelvin, V initial, V final, initial and final volume. Let's write P initial, P final, initial and final pressure. Okay, so this part is also done. I hope everyone has noted this down. Okay, now what is next? This you have already covered, but let's repeat it. Isothermal irreversible process, and how are we going to understand we are talking about irreversible process? What was the hint I have given you? Look for constant external pressure. This is what we are looking for in the question. If you see constant external pressure, look for irreversible process. How do we calculate work done there? Simple formula, minus P external V final minus V initial. This was the formula we have taken up in the beginning itself. Okay, there is a third kind of process that they can ask you, in which they will say that your external pressure is 0. Okay, so they can call it free expansion or expansion in vacuum. Okay, so in that case your work done will come out to be 0. Okay, so now we have learned about three different types of work done. Work done for isothermal reversible process, work done for isothermal irreversible process, work done in case of free expansion, okay, or expansion in vacuum. So you should know three different formulas for work done, then only you can solve questions. Let's move to the next part, everyone. Adiabatic reversible process for ideal gas. This is how we will calculate the work done. NCV T2 minus T1. What is C? Heat capacity. Heat capacity at constant volume. Like that, we have heat capacity at constant pressure also. We will see that as well. Okay, so do we have to remember the formula? Yes, you have to remember the formula. Otherwise, how will you substitute the values? Okay, so this is adiabatic reversible process for ideal gas, and this is how we will calculate the value of work done. Okay, so this is all about the different types of process, but adiabatic process has some other relationship also that you have to remember. For example, in case of isothermal process, if we talk about PV relationship, you will say PV is a constant. This is what you have learned in states of matter. You are correct also, but it is for isothermal process. So is there a different relationship between pressure and volume, volume and temperature, or pressure and temperature for adiabatic process? Yes. Can they ask you questions based on it? Yes, direct relationships are asked sometimes. So if you know the relationship, you can easily answer that question. So please note these three relationships. See, PV relation. What is this here? Gamma. What is gamma? Cp over Cv. Okay, heat capacity at constant pressure, heat capacity at constant volume, and this is gamma. So what is PV relation? PV raised to the power gamma is a constant, not PV is constant. That is for an isothermal process. For adiabatic process, we have a different relation that you must remember. Okay, so this is the first one. TV relation, temperature, volume. This P is pressure, right? V is volume, T is temperature. TV raised to the power gamma minus 1. This is a constant. See, gamma minus 1. And finally, temperature and pressure relation, temperature into pressure raised to the power 1 minus gamma over gamma. This is a constant. So these three formulas also you should know, can be asked directly also. Okay, now okay, let's continue. Now let's move to the next part. Now this value of gamma for different type of gases will remember different gamma values. Okay, so for a monoatomic gas like helium, neon, argon, gamma value is 1.67. Do we have to remember it? Yes, please remember it directly. You have to substitute these values. Okay, so for polyatomic, gamma value is almost equal to 1.3 or less. You will substitute 1.3, that can work. Okay, then for diatomic gas in which you have 2 atoms per molecule, monoatomic 1 atom, diatomic 2 atoms per molecule, polyatomic more than 2 atoms. Okay, so for diatomic gases, these are some of the examples. We are not saying for only these diatomic gases you have to apply this formula. These are the examples of some of the gases which are asked repeatedly in the questions. So what is the value of gamma for these gases? We are just writing that. Okay, so O2, N2, H2, gamma value comes out to be 1.4. Okay, then 1.3 and this one is 1.67. Again important, please remember it. So we are covering the important concepts only so that you can memorize them and use them in your examination, obviously. Okay, see the next one. Enthalpy. Is enthalpy a state function or a path function? See, if they ask you about state function or path function, state function, it only depends upon initial and final state. It does not depend upon the path taken. So how do we remember the different types of thermodynamic quantities, whether they are path function or state function? For your understanding and from your examination point of view, you have to remember work done and heat. If you see anywhere, path function. Rest everything that you see, enthalpy, internal energy, entropy, Gibbs free energy, heat capacity, you will say they are state function. Okay, so enthalpy is your state function. Path function, just remember 2. They will also depend upon the path you have taken, and based on that they will have different values. Enthalpy, no, it only depends upon initial and final state. What path you have taken to achieve that change, we are not concerned with it. Okay, so enthalpy, how do we calculate it? See, there are 3 formulas to calculate enthalpy, and you must remember the 3 formulas exactly. The most common one that we use again and again is this one. Okay, and there is one more that I will write, and you should know 3 formulas, but which one you have to use more and more in numericals, I will tell you that also. Okay, so please see this one. This is absolute enthalpy. We are not concerned with it. We cannot calculate it. Why? Because we don't know the value of absolute internal energy. So how can we decide the value of absolute enthalpy? So what are we going to calculate? Change in enthalpy, change in internal energy. These are the things that we are going to calculate. Okay, so change in enthalpy. There is this formula also, very rare that they will ask you a question from here, but still you should know. Okay, so not very important. This one is important, and there is another one which is important. This one for sure you have to remember. They will definitely ask you a question from here. Okay, this one and this one not important from examination point of view, but yes, you can calculate the enthalpy change. If they give you some new fancy type of question, then they will ask you the first one. Otherwise, second and third are the most important ones. Okay, so this is how you will calculate the enthalpy change. Great. And at constant pressure, we can also write that enthalpy change is equal to heat exchange at constant pressure, or NCP delta T. Okay, so this is one expression that you should know about, and if you want to write it in terms of internal energy, then it is heat exchange at constant volume and NCV delta T. You should know these two relationship also. Okay, so these are some of the important formulas related to enthalpy change and internal energy change also. How is enthalpy change related to internal energy change? We have covered that part also. Okay, so let's see the already covered that enthalpy is a state function, internal energy is also a state function, entropy, Gibbs free energy, state function, path function, work done, and heat exchange. Remember that. Okay, see the next part. Heat capacity. See, the heat capacity can be asked in three ways. Okay, so you can have total heat capacity, you can have specific heat capacity, you can have molar heat capacity. What is the difference between the three? Not much. Heat capacity, how do we define it? It is the amount of heat required to raise the temperature of any substance by 1 degree Celsius. It is known as total heat capacity. Temperature required to raise the temperature of any substance by 1 degree Celsius. Then what is specific heat capacity? Temperature required to raise the temperature, heat required to raise the temperature of unit mass of the substance by 1 degree Celsius. So in specific heat capacity, you are mentioning the mass of the substance that you are talking about. In molar heat capacity, you will talk about 1 mole of the substance. Rest everything is copy paste. Okay, so this is what we have written. Heat required to raise temperature of any substance by 1 degree Celsius. This is total heat capacity. We represent it by capital C. If you write the same thing, heat required to raise the temperature of unit mass of the substance by 1 degree Celsius, you will call it as specific heat capacity. It is written as small c. Okay, and sometimes you may see it is written as C with the subscript S also. So don't get confused, they are talking about specific heat capacity there. Okay, so this notation also you may see. This is per unit mass, and if you want to know about per unit mole, you will talk about molar heat capacity. C with a subscript M per mole. Okay, and how do we write the formula for this? This is your formula. This is your total heat capacity. Heat required, we have talked about change in temperature in the denominator. This is how you calculate the heat capacity. Okay, so this is all about heat capacity. Then you have learned about heat capacity at constant pressure, Cp, heat capacity at constant volume in the formula that we have written just before this. So those are also types of molar heat capacity. Okay, now what is next? Entropy change for a reversible process. Now from entropy change also a lot of questions are asked which are so simple. They will very rarely ask you a numerical based on it, but they will ask you questions like, they will give you a reaction and they will ask you question that whether entropy is increasing, whether entropy is decreasing, disorder of the reaction is increasing, disorder of the reaction is decreasing. So what is this disorder we are talking about? Entropy change. Okay, so how do we define entropy change? It is the change in or measure of, let's write measure of disorderliness of the system. Okay, so if disorderliness is increasing, you will say entropy is increasing. If disorderliness, chaos is decreasing, you will say entropy is decreasing. Okay, and how do we calculate it? This is for reversible process only. heat exchange for a reversible process divided by the temperature will be given to you in the question. Very simple to calculate also. Okay. So this is heat exchange reversibly, and obviously you will take the temperature in Kelvin. Never substitute the temperature in degrees Celsius in any numerical, in any question. Always substitute it in Kelvin SI unit. Okay. What is next? For different type of phase changes, how will you calculate the entropy change? So this is also exactly the same. Enthalpy change is, you have written this information just now. Heat exchange at constant pressure, right? So I am just substituting that heat exchange reversibly with enthalpy change. Okay, so based on the process that they have asked you, whether they are talking about solid to liquid change, vaporization, liquid to gaseous state, sublimation, solid to gaseous state directly, they will tell you in the question. Based on the phase change, based on what type of physical state you are changing, you will substitute that enthalpy value divided by temperature. You can calculate the entropy change. Okay, so these are the different formulas here. Enthalpy change value should be in joule per mole and temperature must be in Kelvin. If it is in kilojoule per mole, accordingly your unit will be kilojoule per mole per Kelvin. As simple as that. Okay. This is the unit of entropy change. Okay. What is next? Now, based on the type of process, if it is a spontaneous process, what is entropy of the universe? Entropy of system plus surrounding. Okay. So, if you are talking about a spontaneous process, entropy of the universe will always increase for a spontaneous process. All naturally occurring process that you see are spontaneous, and for them the entropy changes. Total entropy of the universe is always positive. Okay. So, you can also write this entropy of the universe as delta S total. They mean the same thing. See, for a spontaneous process we have written entropy of the universe is always going to increase. It is always positive for a spontaneous process. Okay. What if the reaction is at equilibrium? In that case, delta S of universe is 0. Delta G is also 0. Okay. What if we are talking about a non-spontaneous process? In that case, entropy of the universe will be less than 0, negative. It requires external energy to proceed. How do we define a spontaneous process? Any process that occurs by itself. You can initiate the process in the beginning, but after that the process occurs on its own. We call such a process as spontaneous process. What about a non-spontaneous process that requires external factors, that requires external support to proceed? We call such process as non-spontaneous. Okay. So this is how you will understand it. They can ask you this question directly also in terms of statement that we are doing a spontaneous process. What can you comment about the entropy of the universe, whether it is positive, negative or 0? So you can easily answer that. Okay. Then last thing, Gibbs free energy. How do we calculate it? Enthalpy change minus T delta S, T temperature, delta S entropy. And we were talking about a table. Let's write that table. Let's cover that part here only so that you can solve the questions later on. Okay. So this is a very simple table based on the sign of enthalpy, entropy and Gibbs free energy. Okay. So the most favorable setup when we are using this formula only, I am just going to write the sign and this is how you will remember it. Very simple to understand, not at all difficult. Okay. So if enthalpy change is negative, entropy change is positive, this is the most favorable scenario. Your reaction will be always spontaneous in that case. Okay. So your Gibbs free energy will come out to be negative, and temperature we don't have to worry about it. Low temperature, high temperature, reaction is always spontaneous. Okay. And if I do the complete reverse of it, complete reverse, that means I take enthalpy change as positive, entropy change as negative, then your Gibbs free energy will come out to be positive, and you understand if Gibbs free energy is positive, reaction is non-spontaneous at all temperature. So this is the least favorable scenario and this is the most favorable scenario. Okay, so this is case number 1, this is case number 2. Then there is case number 3. If both of them are positive, then can we make the reaction spontaneous? You can, at high temperature. Reaction is spontaneous at high temperature. You have to remember this, or you can just substitute the values here. Then also you will come to the same observation. And it is very simple to remember. If enthalpy change and entropy change are positive, at high temperature reaction is spontaneous. If both of them are negative, at low temperature the reaction will be spontaneous. So please remember this table. They will ask you a question based on it for sure. They will not ask you the 4 cases. Okay, maybe they will ask you case number 1, 2, 3 or 4 and you can easily answer it then. Alright. So this is all about the important formulas that you must know. Now let's talk about some questions. Okay. So please note this table down. This is definitely going to be asked in your examination. Okay. See the next part now. Let's solve question. There is a vessel of volume V. It contains an ideal gas at temperature T Kelvin. The vessel is partitioned into 2 equal parts. Okay. So there is some vessel. It is now divided into 2 equal parts. This is a question of extensive and intensive property, you will know. Okay. The volume in liters and temperature in Kelvin in each part is respectively. Okay. So what do you think about volume? Is it extensive or intensive property? Extensive property that depends upon the amount of the substance. Intensive property that does not depend upon the amount of the substance. So volume is extensive. More amount, more volume. Temperature is intensive. Whether I have kept 1 liter of water at room temperature, 2 liters of water at room temperature, it will still remain at 25 degrees Celsius, right? So the amount does not change the temperature. Temperature is intensive. Volume is extensive. So volume depends upon the amount. Extensive. So even if I divide it in 2 parts, the temperature of both parts will still be same. Otherwise, if I have taken 1 liter of water and if I divide it into, let's say, 500 ml, 500 ml, that does not mean now the temperature is also halved. That does not happen, right? If it is at 25 degrees Celsius, whether I have divided it into 2, 3, 4, 5 parts, the temperature still remains same. So that means temperature is intensive. So even if I divide it into 2 parts, the temperature is still T. But the volume is halved, right? Total volume V, I have divided it into 2 parts. So for the first part, volume V by 2. For the second part, volume V by 2. Okay. So your correct answer here will be this. Do we have to solve this question? No. Do we have to understand the concept of extensive and intensive property? Yes. And that is how you solve the questions. Okay. See the next one. The number of extensive properties in the following list. Also, please do remember one more thing. Extensive property depends upon the amount. Intensive property does not depend upon the amount. Ratio of 2 extensive properties. Ratio of 2 extensive properties always comes out to be a intensive property. Okay, write this down. Is this true always? Yes. Ratio of 2 extensive properties is always an intensive property. I will give you one example. What is density? Mass over volume. Mass is extensive, depends upon the amount obviously. Volume is extensive, depends upon the amount. Ratio of the two, density. Density is intensive, does not depend upon the amount. Okay, so ratio of two extensive properties is always intensive property. So density is intensive. Mass and volume, extensive. Okay, so now see the options. Enthalpy is extensive, depends upon the amount. Density, I have just now told you, intensive. Volume, extensive. Internal energy, extensive. Temperature, intensive. So how many such properties are given? I can see I have 3 extensive properties, so my correct answer will be 3. And you are done. Enthalpy, volume, internal energy. And 2 intensive properties, density and temperature. Such a simple question. Okay. This was asked in 2024. So very simple concept based questions are also asked. You have to keep them in mind. Alright. So I hope this part is done. Let's move to the next question. The volume of an ideal gas contracts from 10 liters to 2 liters. Okay, let's call this as V1, 10 liters. Let's call this as V2, 2 liters. Under an applied pressure of 2 atmosphere. Okay. During contraction, see volume is decreasing, contraction, compression. The system also evolved 900 joules of heat. Heat evolved. Heat released from the system, negative. Heat absorbed by the system, positive. Okay. The change in internal energy involved in the system is, and you are given the conversion factor also that you have to remember, 1 liter atmosphere is 101.3 joules. See, they are asking you to calculate this. Internal energy change, right? In which heat exchange is already given to us. I just have to calculate the work done. Okay. And for work done, see, under an applied pressure, which is constant, is given. So what type of process they are talking about? Reversible or irreversible? For constant external pressure, we are talking about a irreversible process, everyone. So can we calculate the work done here? Yes, we can. V2, okay, what was V2 and V1? V2 is 2, V1 is 10. Okay. 2 minus 10. Is this positive? Can you see? If we have written this in the beginning, if delta V is negative, for contraction, your work done will come out to be positive. Do we have to remember this information? No. I told you, if you substitute the values, you will come to the same observation yourselves. You don't have to cram it. See, there was no need to cram it. If you have substituted the values correctly, you will come to the same observation yourselves. And what is the unit? Liter atmosphere. But the heat exchange is given to us in joules. This we have calculated in liter atmosphere. If we are trying to add 2 quantities, they must be in the same units, right? Convert this into joule first. Okay. So this was the formula you have written, 101.3 joules. Okay. So now you have the work done. You have the heat exchange. You can calculate the value. We are not going to calculate it here. We are just trying to understand what we have to solve here. Okay. So this was the question. Please see. Volume, initial and final was given. External pressure was given. We calculated the work done. Heat exchange was given. They have told you that heat is evolved, so it is negative. Use that information. And after that, we have just applied the first law of thermodynamics. We have calculated the work done for an irreversible process, and we can calculate the internal energy change. Done. Simple, easy peasy question. Okay. See the next one. At 300 Kelvin, 3 moles of an ideal gas at 3 atmosphere pressure is compressed isothermally to 1/2 of its volume by an external pressure. irreversible process of 6 atmosphere. The work done is, you have to calculate the work done, but for that I need V final and V initial. I can see the pressure, but V initial and V final is not given to us. Use the ideal gas equation. V is nRT over P. I am trying to calculate V1, then V2 will be V1 by 2 because they have told me that your final volume is half of the initial volume, but we don't know the initial volume. We will calculate it first. Okay, so we know V2 is great, but we have to calculate V1 first. Okay, so how many moles are given initially? 3 moles. Okay, the value of R 0.082. Temperature also given to us. Pressure is also given to us, 3 atmosphere. Okay, so from here you will calculate the value of V1, then V2 you will write as V1 by 2. Once you have the value of V1 and V2, how do we calculate the work done in case of a isothermal irreversible process? What is the external pressure given? 6 atmosphere. So you will substitute that value here and you can calculate the value of work done. I hope we can do the calculations ourselves, understand the entire concept. This is what we are trying to do. Calculation part, obviously after substituting you can calculate it, but what formula to use, which values to use, how do we decide this is the formula, how to decide the type of process, this is what we are learning here. Okay, so I hope this part is okay. Let's move to the next question. At 61 Kelvin, 1 mole of an ideal gas of 1 liter volume expands isothermally and reversibly. See, irreversible process, they are giving you a hint, constant external pressure, or writing that in the question. For a reversible process, they have told you directly. Good, great for us. We know the formula now. For isothermal, minus 2.303 nRT log of V2 by V1. This was the formula, right? Do remember the formula. Okay. Now, write down the values. So, temperature is 61 Kelvin. V1 is 1 liter. V2 is 10 liters. We can substitute the values here. Minus 2.303. Number of moles 1. Value of R 0.08. Temperature 61. Log 10. Log 10 is 1. Okay. Substitute the values and you will get the work done. So was this a difficult question? No. It was not a difficult question. You are just substituting the values directly in the question. It can't be any simpler than this. Then calculation obviously you have to do, but if you know the work done for an isothermal reversible process, for an isothermal irreversible process, the questions will look as simple as this one. Okay, see the next one. So please do calculate the final value and please cross check what will be your final answer. But we have seen the concept, we have seen the formula. I hope we can substitute the values ourselves. Okay, that is your task. Let's see the next one. Identify the pair in which both are not extensive properties. In which both are not extensive. You have to identify one such option in which both the properties are not extensive. Okay, so see. Internal energy, extensive. Enthalpy, extensive. So the pair is extensive. This is not our correct answer. Leave it. Mass, extensive. Volume also extensive. The pair is extensive. Again, not the correct answer. Density, you have just now learned. Density, mass over volume, ratio of two extensive properties is always an intensive property. Okay. So this is intensive? Yes. But they are asking you the pair in which both are not extensive. So this is for sure intensive. Okay. Pressure is extensive. Both are not. Okay. Intensive. Option C is the correct answer. Heat capacity, Gibbs free energy, both of them are extensive. So correct answer will be option C. Density, pressure, both of them are intensive. Correct answer is option C. Okay. See the next question. Okay. 1 liter of an ideal gas at a pressure of 20 atmosphere expands isothermally and reversibly to some final volume x liters by absorbing this much amount of heat. The x is, so what is the pressure? Expands isothermally and reversibly. Okay. So we have V1, V2 we don't know. By absorbing this much amount of heat. Absorbing heat, positive. So we have to calculate the value of x. Okay. So if it is an isothermal process, delta U is 0. NCV delta D for isothermal process, delta U is 0, delta H is 0. So work done is equal to heat exchange. Okay, so you will write so this value will be minus 92.12 minus 2.303, number of moles we are not given the number of moles, we can calculate it. Okay, pressure is 20, volume is 1 liter, universal gas constant 0.082, okay, and temperature is, okay, not given. Let's take it at room temperature, or let's take the number of moles also as 1. No issues. If they have not given you the information in question, leave it as it is. Okay, so leave this part, write this here. Volume 1 liters, okay, don't stress too much if the information is not given. Pressure is 20 atmosphere, great. What else? Isothermal reversible process, final volume x we have to calculate. V2 we don't know. V1 is given to us. Delta U is 0 because it is an isothermal process. So Q is equal to minus W. So minus of minus 2.303 RT log of V2 by V1. Okay. So here you will substitute the value 92.12. Let's write room temperature 298 Kelvin, and you can easily calculate the value of x here. Okay, if they have not given you any temperature, we will assume it is room temperature. We will take 298 Kelvin. If they write any temperature, use that. If nothing is given, consider it to be room temperature 25 degrees Celsius and solve it accordingly. And like that, you can calculate the value of x. Okay, so see the next one. Which of the following is not a state function? I told you, except work done and your heat, every other thermodynamic quantity that will be asked to you in the question will be a state function. Okay, so if you see work done or heat, it will become a path function. So your correct answer here will be option B. As simple as that. Such a simple question. Okay. Now, what is next? Identify the correct statement from the following. For an adiabatic process, delta U is equal to work done for the adiabatic process. Why? Because heat exchange is 0 for adiabatic process. This is first law of thermodynamics. For an adiabatic process, this is 0. So, internal energy change will be work done for an adiabatic process. So, this statement is true. First statement is true. Work done is a path function. This is also true. Volume is an extensive property. This is also true. So, first, second, third, all these statements are correct. They are asking you about the correct statements. Option A. So, that is how they can ask you a question in terms of statement. It will be very easy for you to understand. Not at all difficult. Path function, work done and heat. State function, internal energy, enthalpy, heat capacity, entropy, Gibbs free energy. All of them are state function. They only depend upon initial and final state. Okay. So, see how easily we have solved this question just by reading the statements based on the content we have revised in the beginning itself. Okay. See the next one. Okay. Enthalpy of reaction for this is x kilojoule per mole. What is the internal energy change at the same temperature? They are not asking you to solve it completely. They are just asking you whether you know the relationship between enthalpy change and internal energy change. And you know that relationship. This one, I told you, the most important one. What is delta Ng here? Change in number of gaseous moles. So you will take the number of gaseous moles on the product side, subtract the number of gaseous moles on the reactant side, that will be delta Ng. What type of moles I am talking about? Gaseous moles. Should we include something which is pure solid? Should we include something which is pure liquid? No. Only gaseous moles you have to count. Okay. So what is delta Ng here? I can see this is in solid state, not counted. I have only one gaseous mole on the product side. I will write 1. How many gaseous moles are present on the reactant side? 0. On the reactant side, I have a solid substance. There is no gaseous mole on the reactant side. So, delta Ng comes out to be 1. Great. Let's substitute it here. What is the value of enthalpy? X kilojoule. Kilojoule. Please remember that. Don't forget the unit. And what is the value of delta Ng? 1. Okay. X kilojoule. Delta U we are trying to calculate. This is 1. Value of R is 8.3. See? Joule. Joule per mole per Kelvin, not kilojoule. So should we convert it to kilojoule? Obviously, if you are trying to subtract it from a kilojoule value, you have to convert this also into kilojoule. How can we do that? Divide it by 1000. Okay. So now this becomes value of R in kilojoule. Now what about the temperature? It is 1000 Kelvin. Okay. This is temperature and this is the 1000 we have written in order to convert the value of R from joule to kilojoule. Okay. So delta U comes out to be X minus 8.3 and this entire value is in kilojoule, not in joule. Okay. So, the correct answer is X minus 8.3. This is what was asked to us in the question. Okay. Now, I hope this is clear. So, that is all for today, everyone. Let me see if you have any questions. Okay, we are giving the answers. Okay, any question? Charan, that part you have to revise. Okay, this is a revision session, right? So I expect you to at least know the basics, and after that we can move from there, correct? I hope you are able to understand what I have written after that. Okay. Alright then, if you still face any doubt, then you can ask in the comment box. Okay, the PDF for this session will be provided to you in the description box, also in the Telegram channel. Okay, so you can read it from there. There are a lot more questions that you have to practice. There are a lot more questions for which you have to revise the formulas again and again and again. Then only you will be able to solve it. Okay, so that is all for today, everyone. Let's end the session. Okay, once again, so we are starting with a 1-year maths program. I just wanted to give you one more information. So if you download the sisyaclass app, there's one maths program that we are starting for grade 3 to grade 10. So if you have brothers and sisters who are studying in that grade, then they can take help of the course. So it will be a 1-year maths program, maths and maths only, for just ₹999, and all IIT, NIT teachers will be going to teach you, and you will get the help of Sysya AI also. So you will get the text-to-text doubt solving, speech-to-text doubt solving, image-to-text doubt solving also there. Okay, so you can enroll in the course. It will start from 5th May 2025. In this course, the entire CBSE, ICSE and state board syllabus will be covered. Okay, so that is all from my side. In tomorrow's session, we are going to start with a new chapter. We are going to learn about some more formulas, some more questions, but keep practicing everything from your side also. These are just a few important questions that we have done in the class, but after that, the revision of the important content, solving of the questions, that is your task. Okay, so please do that, and all the very best for your examination. Bye everyone, have a great day.